Okay, so this is the second part of Lesson 8.1, which is using the Pythagorean theorem to prove or classify triangles as right, obtuse, or acute. I guess we could get rid of the word prove up here to classify triangles as right, obtuse, or acute. So you can look at the three triangles and kind of tell which one we think might be a right triangle, which one we might think is an obtuse triangle, and which one we might think to be an acute triangle. But here's how the Pythagorean theorem is going to help us, and then we're going to actually prove it. So if it's a right triangle, we know by the Pythagorean theorem that the hypotenuse squared has to equal the leg squared. So that's an equal sign. All right, really, really important. Those are equal if it's right, okay? If you plug it into the equation and the hypotenuse side is greater than the legs added together, then that's telling you that the hypotenuse side is really, really, really long. And if the hypotenuse is really long, greater than the other two sides, then obviously the angle left across from that super duper long side is going to be a really wide angle, which means it's probably going to be greater than 90 and what we consider to be an obtuse angle. Okay, so that would make it an obtuse triangle. So if the side that we would sort of consider to be the hypotenuse, it won't be in that triangle because it's not a right triangle, but it would be the side that we would sort of call the hypotenuse if it were a right angle, then that is how we determine that if it's super duper long, then it's going to have a really big angle across from it, which would be greater than a right angle. In an acute triangle, it's going to be less than. So the hypotenuse side would be smaller than the other two sides, which means the angle left across from it would be a really teeny tiny angle, which would have to be less than a right angle, or what we consider to be an acute triangle. Okay? So let's test it and see how it works. So in the first example, our hypotenuse, this would be C. We're going to plug that in, 25 squared. We're going to see if it does equal 20 squared plus 15 squared. So 25 squared is 625, and 20 squared is 400, and 15 squared is 225. And if I add these guys together, I get 625 and 625, and it's equal, which means this is in fact a right triangle. Okay? Look at the second example. This is what we would consider to be our C, because that appears to be what we would think to be our right angle if it were an actual right triangle. So we're going to use it that way and test it to see. So 20 squared, and I always leave this box open because I never know, does it actually work or not? So I just leave it there and then I fill it in the end. 15 squared and 10 squared. So 20 squared is 400. 15 squared is 225, and 10 squared, 10 times 10 is 100. Again, add these guys together, 400, and then 225 plus 100 is 325. So 400 is greater than the two sides together. So if the hypotenuse side is actually longer than the other two sides, that means that this is an obtuse triangle. And then the last example, again, we think which one would we use as our hypotenuse. Remember that the hypotenuse is usually the longer side, usually. So we're going to use the longer side to be our hypotenuse. Please make note of that somewhere. If you're given three values, the longest side is the side that we typically use as our hypotenuse. Usually, longest side is hypotenuse. Okay, please make sure you bubble that, highlight it, draw big stars around it, whatever you need to do so you remember that. So 9 squared, I'm putting that in place of my hypotenuse. And then my other legs are 7 squared plus 8 squared. So 9 squared is 81, 7 squared is 49, 8 squared is 64. So 81, and then add 49 and 64, and we get 113. So 81 is less than 113. Less than means acute triangle. So what we're saying to you is we're going to give you 3 values, and we're going to say, tell us what kind of triangle that is, right, obtuse, or acute. So you have to choose the longest side, plug it in for the hypotenuse, and test it. See if it actually works. What do you get for a symbol? Do you get an equal sign, which means it's a right angle? Do you get a greater than sign, which means it's obtuse? Or do you get a less than sign, which means it's acute? You will notice in every one of these equations, we always start with the hypotenuse on the left side. Okay? Really important. Hypotenuse on left side always. Okay? Really important. Really, really, really important. I can't stress it enough. All right, I'm going to scroll the page up. We're going to work on some word problems. See how you do with these. So let's clear the page, and let's scroll it down and start with this first problem. So the question says, a painter leans a 15-foot ladder against a house. The base of the ladder is 5 feet from the house. Draw the picture. Picture is super important. So here's my house, right? I have a ladder leaned against the house, so here's my ladder. Okay, it's a 15-foot ladder, and the ladder is 5 feet from the base of the house, so this distance is 5. Okay? To the nearest tenth of a foot, how high on the house does the ladder reach? So we want to know this distance. How high on the house does the ladder reach? So if you look really carefully, we have a right triangle, and we have a hypotenuse of 15. We have a base of 5. One leg is 5 and one leg is x, so we're actually looking at this little triangle, x, 15, and 5, and we're just going to use it to solve. So my hypotenuse is 15. It always goes on the left. 15 squared equals x squared plus 5 squared. So 15 squared is 225. 5 squared is 25. I'm going to subtract 25 from both sides. I'm going to get 200 equals x squared, and then remember to undo an x squared, we square root. So we need the square root of 200. The square root of x squared cancels. X equals 14.1 feet, because the problem is in feet. Okay? Consider the ladder is too high. By how much should the painter move the ladder's base away from the house to lower the top by 1 foot? Okay. So, by how much should the painter move the ladder away from the base? So we need to know, we're going to move this distance, this base distance. We need to know how much should we be moving it. If we want this to be 1 less than what it was before. So we found it to be 14.1. So 14.1, that's the height, minus 1 gives me 13.1. So I'm going to now use 13.1 as the height of my 15-foot ladder. And I'm going to try to figure out how far the base should be away from the wall. Okay? So let's first figure out the distance of the base. So we have to plug it into the equation. 15 squared equals 13.1 squared plus x squared. 15 squared is 225. 13.1 squared is 171.61 plus x squared. Again, subtract to isolate your variable. So we get 53.39 equals x squared. So we, again, have to square root both sides. So let's square root both sides of the equation, and we get x equals 7.3. So before, the base was 5, so that's before. And now the base is 7.3. The question is, by how much should the painter move the ladder's base away? So how much did we move the ladder? So you have to do 7.3 minus 5, and you get 2.3 feet. That's how much he moved the ladder. Okay? So you have to read that question very carefully. It wasn't asking you for the new base, it was asking you for how much did it have to move it. All right? So let's go ahead and scroll and look at the next two very quick questions. So we'll move the page up. We have these two quick questions to do. A walkway forms the diagonal of a square playground. The walkway is 24 meters long to the nearest tenth of a meter. How long is the side of the playground? So the walkway forms, here's my playground, the walkway forms the diagonal. Okay? The walkway is 24 meters long. To the nearest meter, how long is the side of the playground? Alright, it tells you it's a square. So if it's a square, we know all the sides to be equal. So leg A and leg B are going to be the same distance. So we're going to call them both x, since they're the same. And then we're going to use that to solve. 24 squared, Pythagorean theorem for this right triangle. I know my hypotenuse, and I'm searching for my other two sides. 24 squared is 576. You have an x squared and I have an x squared. If we put them together, we now have 2x squareds. I got to get x squared by itself so that I can take the square root. So I have to divide by 2. That leaves x squared. 576 divided by 2 is 288. And then, of course, we're going to square root to get both sides by themselves. So x equals the square root of 288 is 16.97, which rounds, and gives us 17 meters. So each side is 17 meters. You want to embroider a square design. You have an embroidered hoop with 6-inch diameter. So an embroidered hoop, if you know anything about embroidery, a hoop is circular. So let me draw a little circle over here. And it has a square in it. Pretend this is a square. I know it looks more like a rectangle, but they're telling us it's a square. And it tells us that the diameter of the hoop, so from one side of the hoop all the way to the other side of the hoop, is 6 inches in diameter. And it says, find the largest value of x so that the entire square will fit in the hoop. So would you agree that the entire square is within the hoop right now? I would say yes. We know it's a square, so just like the last problem, we're going to call both of the legs the same distance, and we're going to do exactly what we just did with the last problem. C squared, our hypotenuse, is equal to the 2 legs squared. 36 equals, again, you have an x squared, I have an x squared. We put them together. We now have 2 x squareds. To get x squared by itself, I have to divide by 2. 36 divided by 2 is 18. And then I'm going to square root both sides. When I square root both sides, I get 4.24 equals x. So 4.2 inches or 4.24 inches. And that is how you use the Pythagorean theorem to solve word problems, and also how to use the Pythagorean theorem to classify different triangles.